Good afternoon, participants. Welcome to e-course on plant tissue culture organized by Vinayak Vignan Mahavidyalaya, Amravati. Today we are going to see two different topics in today's session: laboratory instrument and sterilization of glassware washing and sterilization technique. Glassware washing and sterilization technique. Now let us first begin with the laboratory instruments which are required in plant tissue culture laboratory. So I'm going to discuss on today in this session three different topics. One is basic facilities which are required in the tissue culture laboratory, then prerequisites, basic facilities of plant tissue culture lab, and equipments which are used in plant tissue culture labs. So let us go one by one. What are the basic facilities which are required in tissue culture lab? See, typically any laboratory is a place where all sorts of scientific and research activities can be performed under controlled condition. For example, if you have a greenhouse in botany department, then you can optimize the temperature, you can optimize the light, you can optimize many other conditions. If you have incubators, then you can increase the temperature or decrease the temperature. If you have a shaker, then you can increase the speed of the shaker or decrease the speed of the shaker. So there are various sources which are available in the laboratories. Laboratories which are generally used for scientific research may work on different scientific problems and therefore differ in the requirements of a specialist in various fields of science. Obviously, if you have a physics laboratory, then you will have different kind of scientific problems which are deal with the physical sciences, and therefore your requirement in that particular laboratory will also differ. For example, a physics lab would have a particle accelerator or vacuum chamber, whereas plant tissue culture lab would have a laminar hood, a tissue culture room, and many other facilities which are required in a tissue culture laboratory. Let us see the prerequisite basic facilities of PTC Lab. Some prerequisite basic facilities for any laboratory which actively practice plant tissue culture methodologies to grow these plants under in-vitro conditions are these are some of the, for example, washing area, glassware, autoclave, areas for media preparation, sterilization and storage, area for transfer of cultures or area of transfer of media in aseptic condition, environmental control incubators and culture rooms. So these are some of the prerequisite basic facilities for plant tissue culture lab. But as I already told in my previous lecture or session, that some of these areas can be easily miniaturized, or even if they are in a very smaller size, for beginners to develop a plant tissue culture lab, that is not going to affect the performance of plant tissue culture area. For example, washing area. For a commercial plant tissue culture lab, you require really a large washing area, because generally in a commercial tissue culture lab, the vessel is of really a large size. For example, you have a magenta bottles, which are typically like a pickle bottles. So these, therefore, the washing areas has to be large. And again, when they run a batch culture wise shoot multiplication, the single batch probably have thousands of cultures. So you can imagine that as compared to a commercial plant tissue culture lab, I think we would not require such a large washing area for a lab which is just beginning with the plant tissue culture. Next is glasswares also. Glasswares also you require relatively of intermediate sizes. If you have just test tube, tissue culture test tubes, a few conical flasks of 250 ml size, a few thousand liter conical flasks, 1000-liter beakers, a few measuring cylinders like 10 ml cylinder, 100 ml measuring cylinder, 500 ml measuring cylinder, and 1000 ml measuring cylinder. So some of these glassware which I just mentioned in the last 2 minutes, these glasswares are reasonably enough to start with the tissue culture lab. The next is autoclave. Even if you have a small 10-liter of autoclave, which is of very small size, then that autoclave will be enough for any beginner plant tissue culture lab. Again, the areas for media preparation, sterilization and storage, that area also, even if a small lab where you have a autoclave on one side, on one bench you have microwave oven, on bench one you have a hot air oven, and few other equipments like digital pH meter and stirrer, in between whatever the area you have, which is we generally use it for say titration or any other observations of microscope, that area is also enough for a media preparation. But what you really do in a media preparation is you have stocks which are ready, you just take them out from the freeze, okay, and depend upon the volume of the media. Let's say you have a 1 liter of media, then you add approximate 50 ml of macro element and so on and so forth. So the media preparation area, even if it is smaller, that is not going to halt or affect the growth of that particular tissue culture lab. Again, as I told you, sterilization, if you have a small autoclave, that is going to absolutely work for developing tissue culture lab. Storage, any corner of the lab which is clean, which is having a plain and smooth area. If you want to cover it, you can use a blotting paper to cover that area, but basically you can keep the cultures overnight, 2 days, or at max 3 days on a normal bench, which should be dust free and clean. So the area for this media preparation, even if it is a smaller size, it can be definitely work for to develop a plant tissue culture lab. Again, area for transfer of cultures and media in aseptic condition. So this is what is mean by this is basically laminar airflow hood. Now this laminar airflow hood, even if it is a smaller size where barely one person can sit in front of that laminar airflow hood, on one side you have say a forceps, surgical blade holder, on other one side you have distilled water, media, test tubes which are sterilized media, and in between if you have one Bunsen burner and few petri plates to keep and few test tube to keep, I think it is possible to do it is possible to establish tissue culture lab with such a small laminar airflow hood. What is important is that laminar airflow hood should be functional. It should not have any kind of electrical or mechanical or technical problem, and it should be clean. Sometimes what happens if you use the same laminar airflow hood for say microbiology work or for bacterial handling or for some another say fungal isolation work, then you need to fumigate that particular laminar airflow hood with formalin and with the potassium permanganate at least twice within a month, and that can definitely help to have a very clean laminar airflow hood. The last one, which is environmentally controlled incubator or culture rooms, is basically, as I told you, that environmentally controlled incubators are very expensive, and these incubators are utilized by the most of them are utilized for running Arabidopsis culture or cultivation of Arabidopsis or smaller plant size plants in these environmentally controlled incubators, and which are generally used by the Western countries like US or Europe or other countries as well. But in India, since we have typical rooms which are made by 10 by 8 feet or 10 feet by 10 feet, these culture rooms, if you have an air conditioner or a air cooler on one side of the lab, and as I told you that if that lab is clean and dust free, and if you have racks with enough fluorescent white tubes, I think that lab should be work as a plant tissue culture lab. Okay, so that's about prerequisite basic facilities, where what I have been emphasizing is even if you have minimum prerequisite basic facilities, that should able to have enough confidence to develop a tissue culture lab. There is no necessity of having large size equipment or large area to develop tissue culture lab. Now, next about which are the equipments which are used in plant tissue culture lab. The first one is hot air oven. And what is this hot air oven? Hot air ovens are the basically electrical devices which used to which uses dry heat to sterilize. Okay, so it basically releases a dry heat, and that dry heat basically you can keep it at 100 degrees Celsius, 80 degrees Celsius, and that should able to do a dry sterilization. Dry sterilization is generally done with those items which should able to sustain that dry heat. So typically hot air oven is a type of dry heat sterilization, and this dry heat sterilization is used on equipment that cannot be wet first thing, and on the material that will not melt or catch a fire or change a form when exposed to high temperature. So when I'm saying that it should not melt, that technically means definitely that you should not use any plastic ware. You should not drop any plastic which is not temperature sensitive or thermosensitive. If it is a very normal quality say plastic ware, then it is going to melt inside the hot air oven. Similarly, if you keep any kind of say chemical or anything inside this, it will basically catch a fire. So that should not, for example, if you keep a paper at more than 100 degrees Celsius, it might catch a fire. So don't keep paper, don't keep plastic, but you can keep all types of glasswares which can easily tolerate that hot air. And whenever you wash those glasswares and keep in this hot air, they are going to get clean and they will be dust free. So the working principle of this hot air oven is based on fine gravity air convection in an electrically heated chamber. Okay, so there is a air which is moving inside this hot air oven with the help of electrically heated chamber. Now these machines are also equipped with various components and it is to ensure the uniform heating throughout the chamber, because you have to have a uniform heating inside the chamber. So there is various components. For example, two jacket design, automatic control unit, PID control, and PT100 sensor. This is the thermo sensor, and there are the temperature presets as well. So these are some of the devices or the components of that electrical component of that particular hot air oven, which basically allows machine to work efficiently and return to a normal temperature when the test process is over. Basically, when you switch off, they will come to a normal temperature, and when you switch on, and whatever temperature you want, let's say you want 80 degrees Celsius, then that will that machine will this component will help that machine to reach at 80 degrees Celsius. It is also necessary for drying washed glass goods, basically all types of glassware. For this purpose, a number of enamel trays of different sizes are required for keeping wet glass goods inside the oven. So all the types of glasswares, like for example petri plate, test tubes, glass rods, smaller test tubes, conical flask, beaker, measuring cylinder, larger conical flasks and larger beakers, all you can keep inside this hot air oven. Now sometimes it is better to use these enamel trays if the your glassware are very small, because they can easily drop from the frame which is inside the hot air oven, and therefore sometimes using those enamel trays, because enamel trays do not catch a fire inside this hot air oven, and it's sometimes good to have this kind of enamel. But if you don't have it, that still be okay to have a dry sterilization of these glasswares. So this is a hot air oven. I think most of your labs which are there in most of the smaller colleges and institutions in our India do have a hot air oven in physics lab or in chemistry lab, and sometimes in botany and microbiology labs as well, because this hot air oven basically dries everything. If you want to dry, let's say plant material or any kind of other material, you can dry very easily. Any kind of a tissue you want to dry, or do some kind of a dehydration test, or you want to basically dry the glasswares, these kinds of ovens are plentifully available in India with lots of vendors. The next equipment is the equipment which is used in plant tissue culture lab is autoclave, and autoclave is basically just like a pressure cooker. It is a seal device that kills the microorganism using saturated steam under pressure. So it builds a pressure, and that pressure is enough to kill the most of the microorganism. Now this is called as a wet sterilization technique. So use of this moist heat facilitates killing of microorganism, including even heat resistant endospores, which is achieved by heating the material inside the device at a temperature above boiling point of water. So basically, when you increase the pressure at some higher pressures, what you can do is you can reach a temperature of water which is above boiling point of what generally at 100 degrees Celsius water boils. But if you want to want higher temperature, like typically the autoclave temperature which is keep for doing wet sterilization is 121 degrees Celsius. So that is the temperature, or 121, sometimes in 125 or 130, but generally 121 to 120 degrees Celsius temperature is enough to kill heat resistant endospores and all types of bacteria which are randomly present on the surface of glassware, if at all there, because we generally wash the glassware and which we keep it clean. But if at all by any kind of a random process, if there are any spores which are present in your media, outside your media, in your glassware, outside your glassware, all that is going to get killed at such a high temperature. Now this is according to the principles of gas law. The rising temperature, getting the temperature where we can reach 121 degrees Celsius of a water, that can be moist heat can be achieved by raising a pressure inside the device. So if you increase the pressure, there will be increase in the temperature, and that is typical what the principles of gas law suggest. Now autoclave comprises of three parts. One is a pressure chamber, a lead, and electrical heater. So pressure chamber consists of a large cylinder which is either vertical or horizontal, in which the material to be sterilized are placed. So there is one large cylinder which could be either vertical or either horizontal, and in that stainless steel large cylinder we can place our material. For example, what kind of a material we place inside this autoclave is basically all types of glassware. For example, a 250 ml conical flask with distilled water, cap with aluminum foil. Similarly, 20 ml of nutrient morassic Scoop media, polymerized agar or semi-solid media, which is poured on a test tube plugged with the cotton plug. And when we have bundles of these test tube, we can keep them inside this autoclave. We can also autoclave petri plates wrapped with some kind of a paper. We can autoclave even brown tissue or any kind of a soft tissue or soft paper which we need to absorb the water from the seals after the surface sterilization. So forceps, surgical blade holder, any kind of say empty beaker, all these kind of items which we can sterilize very easily by using this autoclave. And it is made up of gunmetal or stainless steel placed in a supporting iron case and along with the steam jacket. Okay, so the steam jacket basically also called as a water compartment. Now lead is generally fastened by screw clamps, so you can move the lead in a clockwise direction or anti-clockwise direction. Generally clockwise direction is fasten the lead, anti-clockwise is loosen the lead. So and basically this type of a lead will render the air tight by an asbestos washer. So there are washers which are present at the tip of the lead or at the bound circumference of the lead, which basically hold the lead so tight that there is no leakage of air between the lead and between the chamber. So lead basically bears the following items. For example, discharge tap for air and steam discharge, a pressure gauge which can set the pressure at particular level, and safety valve. So safety valve is to remove excess steam. Pressure gauge is the one where we can set that pressure. Now generally we keep pressure at 20 psi and that 20 psi pressure will give us 121 to 120 degrees Celsius temperature. The discharge tap for air and steam discharge is generally placed at the bottom of this autoclave. There is an electrical heater which is also attached to the jacket, and that heats the water to produce a steam. So there is at the bottom of the entire autoclave that we will find the electrical heater, and that cord will go to the socket, and when you plug it, when you switch it on, the autoclave will start working. So these are the different types of autoclaves which I have shown in this figure. The pressure cooker type, which is a very small one, and this type of a pressure cooker or this type of a vertical pressure cooker where this blue laser pointer is moving, these two types of pressure cookers are typically those pressure cookers which are used, or autoclave which are used in a plant tissue culture lab when the labs are reasonably small. So these are the two one, the common laboratory autoclave, these one, or this large automatic hospital autoclave or horizontal autoclave. These two are generally used where you want sterilization, with sterilization at a very larger scale. So commercial tissue culture companies generally use this horizontal autoclave or this large automatic hospital style autoclave. But generally in a small labs we can use this pressure cooker type or vertical autoclave, which is generally of 20 liters, 10 liters, or sometimes 50 liters as well. So these are the different types of autoclave which are utilized in plant tissue culture labs as well as in other purposes as well. So what is the procedure to operate this autoclave? Basically you place the material inside the pressure chamber and fill that particular cylinder with the water, normal tap water. Close the lid and put on electrical heater. So you switch it on. Then close the discharge tap. Steam pressure rises inside and it reaches to 15 pounds or 15 lbs per square inch, that is 15 to 20 lbs per square inch. And after reaching that temperature you should count the holding period, means you start counting the time, and once you have on timer 20 minutes are finished on that particular incubation time of when the temperature reaches at 15 to lbs, then after 20 minutes basically that is the autoclaving timing. So in this autoclaving timing, now this autoclaving timing, which is we call 20 minutes or 10 minutes, is the time enough for those endospores and any other bacterial spores or bacteria which are present inside and outside the medium, inside and outside the glassware, will get easily killed. So this time is basically optimized with with various experimentation. Now generally if the volume of the medium is very large, let's say more than if you are having magenta bottles, or if you are having conical flask of say 200 milliliter where you have 100 milliliter of media or more than that, then whenever you have larger volume other than the 100 ml of media volume of one single vessel, in that case you should have maybe 25 to 30 minutes of autoclaving timing. And that time, autoclaving time, is important because if the volume is large, then you require a larger time to ensure that you don't get contamination at all. Sometimes it is found that if you hurriedly finish this autoclaving period, instead of, sometimes what happens, students want to go early, or if anyone who is working with autoclaving, he want to just finish the work early, he, instead of counting 20 minutes, he counts in just a 10 minutes or 5 minutes and then switch it off. So in that case what happens, there is a likely chances that you will have some bacterial or fungal contamination in your media in spite after sterilization. So one has to confirm even after 20 minutes that whether your sterilization is sufficient enough to eradicate those contamination. So generally it's better to wait for 1 or 2 days after you autoclave the media, and you just keep it on normal temperature in your lab benches. That will get solidified after few hours, and after solidification, if within a 24 hours if you see any kind of a bacterial colonies or fungal colonies, that clearly means that autoclaving time is not enough for that particular. And that could happen. There could be many reasons why it would happen, but generally if you find this repeatedly, that you are getting contamination the minute you autoclave your media, I think it better to check the autoclave. You can change the water. You have to change the water of the autoclave, which is generally present at the bottom of the autoclave quite frequently, because it is also staying there for a very long time, and therefore it can get contaminated as well. So after holding this period, stop the electrical heater, allow that autoclave to cool until the pressure gauge indicate that the pressure inside of the autoclave and outside is same, which generally reaches to 0. So that that pressure knob, when it reaches to 0, you basically slowly open the lid and allow the air to enter the autoclave and basically get out the vapor which is hot enough. And once the vapor is getting spreaded out inside the atmosphere, you can remove the sterilized material and you can store it in a proper place. So that's about autoclave. And autoclaving work has to be done meticulously. If you do autoclaving with you know with hurriedly, if you do it, then you might end up having various problems in your media. The next equipment in which we are going to use in PTC Lab is a refrigerator. And why we require a refrigerator or any freeze is because we want to store essential various thermolabile chemicals like vitamins are thermolabile, hormones, plant growth regulators, basically both cytokinin, auxin, gibberellin, and any others. They are basically thermolabile as well. Amino acids, casein hydrol acid, yeast extract, coconut milk. So all these components which are made up of organic carbon, they are thermolabile, and the temperature which is present in Vidarbha or in central India is reasonably high these days in summer, and therefore you can imagine if you keep these chemicals in any kind of a cupboard which reaches the temperature more than 40 degrees Celsius, then these chemicals will lose their functionality. So it is better to keep all these chemicals inside the normal freeze. Now also you have to make sure that your fridge should work during summertime, because compressor catches a lot of pressure, it keeps working all the time, and there is likely chances that your refrigerator may not work. So you have to see the functionality of these all equipments and observe them. If you just ignore the functionality, you open the door and the refrigerator is not showing enough cooling when you touch to the surface and you're just ignoring it, then it is going to in fact create more and more problems. So it's always good to see the functionality, repair the equipments, spend some time with the process of repair. And generally we sometimes it depends, some people avoid it or ignore it, and that does create a lot of problem if you want to have a successful plant tissue culture. Apart from these chemicals, you can also stock, those are the stocks which we are going to discuss in a couple of next lectures. Is as I told you that Murashige scoop media has a macro element stock, micro element stock, vitamins source stock, then it has iron source stock, and these stocks are basically concentrated solutions, and these need to be stored inside the refrigerator or freeze. Because sometimes you will have the fungal contaminations and fungal growth will appear on the surface or on the top surface of these liquids, and therefore once you get these contaminations, the stocks are of no use, you just have to dump it. So instead of having this stock solution getting contaminated, if you keep at room temperature, it's better to keep them in a freezing condition or cooling condition. If let's say if you make some stocks which require some larger storage time, then in that case it is better to freeze it. So that is something important. Okay, so the next component of today's discussion is equipments which are used in plant tissue culture lab, like weighing balance, distillation plant, pH meter, or plate cum stirrer. These are also important equipments for plant tissue culture lab. Any electric or electronic balance which is required for weighing chemicals, sugars, agars, different types of inorganic salts. We need to weigh all these salts, and therefore you require a very good quality fine balance. Again, you require single distillation apparatus, double distillation water plant is also important. But let's say sometimes your distillation apparatus fails or it doesn't work. In that case, do you have any choice? No. Reverse osmosis water, which we call RO water, can also work sometime, but you have to make sure that your stocks or your media, when you are preparing those stocks, those salts do not get precipitated. If they are getting precipitated, that means your water still is not pure. It is having some contaminants, because of which there is a precipitation can occur. So single distillation apparatus, double distillation apparatus, if you have, well and good. If you don't have it, RO can still work. Again, when you add into a distilled water macro element stock, micro element stock, iron source stock, vitamin source stock, then you weigh the mesoinositol sugar, mesoinositol, dispense it, then you measure sucrose, again add into your solution, and if you have a say plant growth regulator, then you add the appropriate volume. After adding all these things, you have to adjust the pH. Now, generally we adjust the pH between 5.6 to 5.8. Sometimes you can even keep 5.85 or 5.88. So that is enough, because what happened during little bit of autoclaving, there is a slight reduction in the pH, so it can lower down the pH of that particular solution. But it is always keep the pH in this particular range. What we keep in India is generally 5.8, because the agar generally get polymerized or solidify at that particular pH, and therefore it is good to keep the pH, as well as there are other reasons that at this particular pH also there is a reasonable amount of ionic transfer which happens from cell to cell in our explants. Now the last one is magnetic stirrer or hot plate. This is, if at all, if you have it, well and good. If you don't have it, you can still stir your solution with the help of glass rod. But this is any magnetic stirrer which is plentifully available in our country. It is a device used in laboratories consisting of a rotating magnet that creates a rotating magnetic field. And therefore this is a device. If you have a small magnetic stirrer bar, you just immerse in a liquid that will start spinning quickly, and it will mix the solution. So magnetic stirrer along with the stirrer bar will help you to mix the solutions quickly, and you can prepare the stocks in a very short period of time. So these are and they also have a heating system. If at all you want to heat some of the solutions a little bit, you can use the heating mantle which is available on the top portion of the magnetic stirrer. So that's about those minor equipments. Now there is another equipment which is also important, microwave oven. Now this microwave oven, why we are using, in older days people used to boil the media by using water bath. Still some people are using it, but microwave oven is quick enough. It has a capacity to melt your agar and prepare the solutions. Now microwave oven uses microwaves to heat the food. It is basically a radio waves. The commonly used radio wave frequency is 2.5 gigahertz, and the radio waves in this particular frequency of 2.5 gigahertz are easily absorbed by the water. So when they are absorbed, they are basically converted directly into any kind of atomic motions, and there is such a intensive atomic motion which is basically converted into heat. And once the water is heated, obviously the media and the solution, the agar, is going to get polymerized and melt easily. The agar won't stay in a solid form, it will start melting. So during media preparation, heat that particular solution for 1 minute or 2 minutes of interval until all of the agar is completely melted. Now you have to make sure what happens when you add agar. The agar gets settled down at the bottom of the vessel, and therefore you should take a glass rod and mix the solution whenever you finish that microwave activity. And because that will get uniform, there will be uniformity of agar in entire solution or entire media, and therefore till it melts completely you should mix it at least 3 to 4 times, and that will definitely give you a very homogeneous liquid or polymerized melted agar media in your beaker. The beakers generally get reasonably hot, so you should not hold by normal hands. You should wear gloves or handle with some kind of a cloth, and then pour that agar into that kind of a beaker where you can handle that beaker to pour that media into test tubes or conical flask. So don't pour this media. If you have prepared the media of say 500 milliliter or 1 liter of media into a 2 liter of beaker, then you should not pour it directly, because it is hot and one cannot hold that entire 1 liter of beaker in a normal hand. And therefore you should pour that agar hot media into a smaller beaker of say 250 milliliter or 200 milliliter, and you can hold that beaker, the beaker which is whatever the beaker which you can hold it comfortably. You should hold it at the top of the beaker. If you hold at the bottom of the beaker, your hands is going to get you will have it will get disturbed. So you should not hold the beaker at the bottom, you should hold it at the top of the beaker. So these are the equipments of plant tissue culture lab. This is the red laser pointer showing a digital balance, a fine balance. If you have a smaller than that, that's still okay. This is a distillation apparatus, and that distillation apparatus is a single distillation apparatus. You can have a double distillation apparatus, but as I told you, any kind of a distillation apparatus will give you a single distill water. If you have double distill water, that's well and good, but double distill water takes a lot of time to basically collect the water. So sometimes single distillation apparatus is much better than double distillation apparatus if you require a lot of distilled water. This is a pH meter, a tabletop pH meter. This is an electrode, and this is a electrical component where we can see the pH. You have to calibrate this any pH meter, and once you calibrate the pH meter with the pH tablet of 7 and 4, which are cheaply available, then only you should use the pH meter. You should not use a pH meter without any calibration. This is a magnetic stirrer with a hot plate. So whenever you want to increase the temperature of that hot plate, you can use this knob. Whenever you want to stir this material, you put a glass magnetic rod inside this, and this basically knob, when you move it on a clockwise direction, that rod is going to move with a faster speed, so that can get mixed up quickly. This is a microwave oven, and this microwave oven will, you just put this beaker inside this particular beaker, in this particular area of microwave oven, and then switch it on, put some time and of medium size frequency, and that will basically melt the agar. So these are some of the smaller equipments which are required for plant tissue culture. So with that, if you have any questions, you can drop those questions in a YouTube channel, as well as you can drop those questions to my email box. I will be able to answer it. So thank you.